All right, cool guys. I can't believe it's the last week of summer. I hope that you got a lot of practice and maybe saw some new stuff and really are just going in with a lot more confidence than you would have otherwise. What we're going to talk about today is derivatives again, but this would be the shortcut way, and I almost feel guilty showing you this video for two reasons. Number one, your teacher will be disappointed that you already know this when you come in because it's I don't want to say it's a way to get around or to cheat other things, but you're now going to be able to check your answers on the types of homework problems that came from last week or even the week before. So instead of having to do the limit definition where you have to do, all of that madness that we were doing the last couple of weeks. Okay, I'm going to show you a shortcut to where you could do this, but you won't have to because it's a shortcut. So without further ado, let's see what the shortcut is. Oh, I didn't give you the second reason. The second reason that I feel guilty for showing you this is because of the fact that you might get angry because I made you do this the last 2 or 3 weeks, and now I'm like, psych, we can do it a different way. Okay, the power rule. Here we go. Basically, the idea is that if you have a function that is x raised to some power, okay, and you need to do the derivative, then all that you have to do for the derivative is to take the exponent, move it to the front, and then subtract the exponent by 1, okay? And that is always going to give you a derivative term. Of course, there's going to, there might be things that are tricked up that we have to deal with, and that's what this video is about. But this is the most basic definition of the power rule. Now, before I get into the other rules, let me talk about notation for derivatives. Y'all remember, hopefully, that derivative is just slope. Okay, it's the same thing, right? Derivative is slope. I think in one of the videos I was labeling it as an M. Another way that people label derivatives is the following. You may have seen back in Algebra 2 or Pre-Cal, some teachers like to write delta y over delta x for slope because that just means change of y over change of x. And since that little triangle is called a delta, some people start to label it as dy over dx as delta y over delta x, or change of y over change of x. And that right there, folks, is the notation for a derivative. So during this video, when I answer a problem, you'll see me doing that right there, okay? All right, cool. So we'll practice that in a minute. But let's talk about the constant rule. Now, the constant rule just pretty much means like if you are given a number. So C is a number. I don't care what number, negative, positive, whatevs, but it's got to be a real number. But as long as it's a real number, then the slope of that, or the derivative of a number, is just 0. Now, I hope this makes sense because if I asked you to graph, don't even write this down, I just want this to make sense. If I told you, hey, graph the function y equals 4. Well, y equals 4 is a graph that looks like this, right? And if we're looking for the slope of that, well, what is the slope of a horizontal line? It's 0. I mean, you've known that since Algebra 1. Okay, so hopefully now that I'm writing it as a rule, it still makes sense. And like I said, you didn't need to have that. All right, cool. So let's go ahead and actually practice these. And the first one's talking about when it's legal to split things up. And I probably titled that poorly because, well, I'm not an English person. But the idea here is that, I want to show you an example when you're given like f of x and there's like multiple terms. I want to talk about splitting things up. So if you have something like 2x to the third minus x squared plus x minus 14, something like that. Okay, so it's legal to split it up if ever it's subtraction or addition. And that's kind of the main idea. That's like 100% of the time, if you see add or subtract, you're going to split up every single term, and then you're going to run through one of these two rules to get your derivative, okay? So the derivative for this, the dy dx, is going to be the following, okay? So I'm just going to take this step by step and go slow, and hopefully it'll make sense. Okay, so when I look, I need to first just kind of examine this one. And the rule is you take the exponent and bring it to the front. Now there's already a number there, so what do you think you do with the two numbers? Hopefully you're thinking multiply, because that is correct. If the 3 comes out here, it's really just a 3 times 2, okay? And then your x is now to what power? Well, the rule says to subtract 1, so 3 minus 1 is 2, okay? So that term turns into that. Now the next one is you want to analyze a negative x squared. So same thing, we take our exponent, move it to the front. Now there was already a negative there, so don't forget that negative too, okay? And then it's x to the what power? Well, now it would be to the first. Now I'm not going to write the first power because people just usually don't. If you want to put the 1 there, I mean, that's fine. It's just most people don't. Now for the next one, I need to think about, you know, what's going on here. What is the invisible power that you can't see? Well, it's the 1, like I mentioned over here. So what do we do with that? Well, we bring the 1 to the front, okay? And there's a plus sign there, so plus 1. And then it would be x to the 0. Now, what is x to the 0 power, guys? X to the 0 is just 1. So really, this part I'm going to erase because I don't need to write 1 times 1, okay? So that just turned into that. And now the last one is, of course, the minus 14 at the back. That 14 is just a number or a constant. So if we use this rule, it just goes to 0. Now I'm not going to write minus 0 because it doesn't matter. So I'm just going to leave it like this. Now here's what's super freaking awesome about this. This derivative that looks like it's pretty long, okay? This is the same answer that you would get if you did the limit definition, this thing up here. If you did that with all of this huge equation and did all that algebra and all that canceling and factoring and blah, okay? If you did that, you'd get the same thing. So way, way quicker. All right, cool. So that's definitely a when it's legal to split things up. All right, so how does this get more difficult? Because this seems I hope this seems easy, okay? Now, rewriting before you start. This is the #1 place, this one right here, that my students had a horrible time with, okay? And I can't do this with a formula. I'm just going to have to actually make up an example because there's no like rule I can really write out. But an example would be something like the following. Like if you're given, let's say it's like 3 over x to the 4th. Sorry. 3 over x to the 4th. There we go. Okay. If you're given this, there is a lot of people that are like, number one, they think they can't do it, okay, because it doesn't look exactly like this. Or there are people that think that they're just supposed to leave the 3 alone and the x alone and just do the numerator and denominator separately. No, 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 that does not work. So please don't just say, oh, the derivative of the top is 0, the derivative of the bottom. No, don't do it like that. You have to rewrite this before you start, okay? And the way I want to refresh your memory is a rule of exponents, where if you have x to the negative a power, remember that's the same thing as that. Okay, that's an old exponent rule. I think we've even done it this summer. So what would you do? Well, you would rewrite this, okay? So the 3 on top is just a 3. It's nothing special. And then you just recopy it. And then x to the 4th on the bottom is the same thing as that. And hopefully this makes sense after looking over here at this exponent rule. Now look, now this does look like what we've been doing, and you can totally use your rule. So if I want the derivative of this, the dy over the dx, delta y delta x, then I could just bring that exponent to the front. So negative 4 times 3, and then x to the what power? Be careful here. Remember, you are subtracting 1. And negative 4 minus 1 is actually negative 5. So be super careful when subtracting a negative from a negative. Okay, and this is kind of an ugly answer, not going to lie. If you leave it like this, you will get points taken off because negative exponents are ugly. So you are going to want to go back and turn it into this form that I just circled up here. The way that you're going to do that is, well, negative 12 is just a number. So it's just on the numerator. And then x to the negative 5th just means I can shoot the x term down to the bottom and leave the 5th on it. And that is how you want to write your final answer. Yay! So it takes a little thinking and slowing down, but it's not horrible, okay? The other ones that students miss a lot are radicals because they think, once again, if they are given something that, you know, maybe it's like this. Oh, I don't want a 4. Let me do like, let me just do like that. Okay, if they're given something like that, they think that it's impossible because it doesn't look like the thing that's above. So you first need to rewrite it. Now, hopefully you guys remember there was a rule from, I don't know, algebra. You've seen it since algebra, but you may not remember it. It was something like this. If you have a square root of x to the b power, that you can write it as a fraction exponent. And it looks like that. So you just need to rewrite this problem so that you can take the derivative. So what's the invisible number here? Well, on a square root, if there's nothing written, it's always an invisible 2. And what's the invisible power on this x? Well, when nothing's written, it's a 1. So your first step would be to write this as x to the 1/2, just following this model over here, okay? Now what? Now let's take the derivative. And whenever we do that, what's going to happen? Okay, so the exponent's going to come out front. Now there's nobody to multiply it with, so yay. Recopy the x. And now what do we do with that 1/2? We subtract 1 from it, okay? So what's 1/2 minus 1? I think that's a negative 1/2, is it not? Yes. So are we finished? No, we're not. We have a negative exponent and it is ugly. So this 1/2 I'm going to recopy as a 1/2. And I made the fraction bar bigger because I know with the negative exponent that this x is going down below. Okay, so I could write it like that. Now, I'm not going to lie, sometimes you'll see it like this, but most of the time you want to simplify that even further because of the fraction exponent. A lot of teachers want you to go back and make it look like a radical. So this could be written as 2 square roots of x, just working backwards from what we did in the beginning. So it's almost like you rewrite it, you math it out, and then you go back to the form that you started with. That's kind of how this works. But there we go. We did this derivative without having to do the limit definition and conjugates and all that biz that we were doing over the last 2 weeks, okay? Now the last thing we're going to do is this whole, well, what if it's a weird function not in a good form? And once again, the title of this is kind of lame, but that's what my brain thinks, is I see something and go, oh, that's weird, and I don't like the form, and so there you have it. What this is talking about is something like this, like, okay, maybe it's like the cubed root of x over 3x squared, something like that. Okay. So if you see this, oh my gosh, right? Like this looks really ridiculous and it looks like you can't do the problem. But remember, like above, please don't think I need to just do the derivative of the top and then I do the derivative of the bottom. No, no, no. You cannot use these shortcut rules until you get it to look like x to some power, okay? So you just have to simplify this. So I'm going to do a couple things. I'm going to rewrite it. So I'm first going to rewrite this. There's an invisible 1 here. So this is x to the 1/3 power. And then on the bottom, I'm actually just going to leave that alone because it already looks okay. There's no radical. And now I'm going to use another rule from algebra with exponents. Do y'all remember how you can simplify if there's an x on top and an x on bottom and everything is being multiplied or divided? You are supposed to be able to just subtract the exponents, right? So x to the a over x to the b is the same thing as this. Okay, so just top minus bottom. So I'm going to rewrite this when I'm still rewriting. I haven't even taken a derivative yet. I'm going to rewrite this as 1/3 because that 3's on the bottom and there's an invisible one there. So 1/3 and then x to the, what power would that be? What is 1/3 minus 2? Let's put that over 3, which makes that a 6. So I'm getting negative 5/3 power. Okay. And now that I've done all this work to rewrite it, now I'm ready to do the derivative, okay? So I take my exponent and I move it to the front. So I'm going to be doing 1/3 times negative 5/3. And when I multiply those, remember fraction is just top times top, bottom times bottom. So negative 5 times 9, or over 9. And then x to the, now what? Now I take this and subtract 1 from it. So subtracting 1 is the same thing as subtracting 3 over 3. So negative 5 minus 3 is negative 8 over 3. So this is looking pretty good. By the way, that is an exponent. I just had to write it big, and so I'm sorry. So to fix this and clear it all up, I'm going to have a negative 5/9. Big fraction bar now. The x goes on bottom because it has a negative exponent, and I could do it like this, or I can go back into the radicals just like I did on the last one. So what would that be? If it's x to the 8/3, which number comes out in front of the radical? It's always the denominator, so the 3 would go here, and then x to the 8th would stay right there. So this is probably how I would make my students write their final answer. Get good at that, and things will be great. I can't tell you how important this is. This is one of those things that I've been in some schools where we can spend 1 day on it or only 2 days on it, and everybody's got it, and it's great, and all year we're fine. And I've been in some schools where we could spend 2 weeks on it and people still don't get it. It's going to be your algebra, and how good are you at recognizing, ooh, I can rewrite, ooh, I can rewrite, and noticing it everywhere. So please don't underestimate algebra when you are in calculus. It is the basis of everything. And if this is easy for you, go back to school and give a big fat thank you to your Algebra 2 teacher or your pre-cal teacher, because if this makes sense and this is easy, they did a great job of giving you enough problems to where you feel confident, okay, and you're able to actually do this and to see the math happen. And if you are having a hard time with it, then go slap them. Ha, just kidding. All right, we'll see you guys on the next video where we work out all the solutions. Good luck.